All right, everyone. Welcome to the July community call with Hasura, where we are focusing on our DDN Advanced showcase. We are so excited to have you here. My name is Rob Dominguez. I am an engineer here at Hasura and the host of your community call. We're going to jump right into our agenda so we can get a better idea of what's going to happen over the next hour. We've taken some feedback because we usually put our customer spotlights towards the end of these community calls. However, we are going to shift it to the beginning just so that we make sure that we honor everyone's time. We're going to hear from Jesse Matlock from Renaissance Learning about how they have helped thousands of educators, students, and parents by integrating Hasura. Additionally, we're going to take a look as kind of the, like I said, the main focus today of DDN Advanced and look at some use cases for multi-repository setups, how you can split subgraphs across different repositories, and have a little better federation features there. Continuing on with everything, we're going to unveil a new native data connector today, being our GraphQL connector. So for anybody looking at bringing in existing V2 projects or GraphQL schemas and APIs into their DDN projects, you can now do that as well. We'll look at multi-source query filtering, so how we can actually make queries across different sources and respect predicates and things like that. Before we cap things off with two kind of more housekeeping sections, I would say, the RFC for REST APIs, and then a little bit of product updates that we just want to squeeze in towards the end here. But for now, we're going to go ahead and jump into things. I'm going to go to the next slide here. Like I said, we're going to start with our customer showcase. So Jesse, if you can hear me backstage, if you'll go ahead and join me up on the stage right now, I'm going to stop sharing my screen. Jesse, how are you?
Hey, how you doing?
Doing well. Jesse, where are you joining us from? Southern California, is that right?
Yep, Southern California, about an
Thanks.
hour south of Los Angeles. So,
All right. Thanks for making time for us this morning. I know it's early over there.
yep.
So you and I talked a little bit earlier in the week, kind of got an idea for how Hasura and Renaissance Learning kind of came together, what you folks use us for. But for everybody on the call that's not super familiar, do you want to give us a little bit of background and history about yourself and then also about Renaissance Learning, just so we can get an idea of who we're talking to and why we're talking to you?
Yeah, sure. So background, been involved with IT related positions for the past 20 years or so. Started off doing support calls for IT and then moved over to doing software. And then now I'm a staff engineer over at Renaissance. So been here for about 5 years or so. Prior to this, I was at a genetics company, which was a fun job, but very, very complicated. Learned a lot there. So that's a
So what
little
you're
bit
saying
about
is
me.
education is easier than genetics?
Much easier, yes.
Okay, okay.
It makes more sense in my head. Um, so yeah, Renaissance Learning is a SaaS company and analytics company for cloud-based pre-K to 12 educational software. So some of our products you may have heard of is Star, Accelerated Reader, Freckle, Nearpod, Lililo. We have a big list, but Star and Accelerated Reader are the ones we've had for the longest. Those ones started around in the 80s. So I
I was gonna
actually used
say, yeah,
Accelerated Reader. Yeah,
I did
for
too.
bits. So
I'm remembering like an old terminal in the library,
yep, yep,
dot matrix printers next to them. Yeah, this
yeah,
is PTSD and this is aging us, but yeah, keep going.
yeah. So that's a bit about Renaissance and myself. Yeah,
Yeah, awesome. So side note, I was an educator for almost 10 years and
okay,
had some run-ins with your products as well. A lot
awesome.
of fun to use them and very helpful. Teachers, especially nowadays, are focusing more and more on the data analytics side. And there's always kind of
Yep,
been this debate, right, of is education an art or a science? And I think, with the tools that you guys are putting out there, we can be more scientific about the way that we teach kids. And yeah,
yeah,
it's very helpful.
yeah.
So yeah, how did you guys run into Hasura? Like, where did you discover it?
So at Renaissance, I was on a different team a couple years ago, and one of my coworkers, we had a middle layer API that was just cumbersome and annoying to work with. It was a GraphQL API, and we wanted to add caching and authorization and some other things to it. And he proposed using Hasura, and he did a POC on it for a few different projects, and this was one of them, and it worked great. So that's sort of how it got thrown into my mind. And so on a different project a few years later we had to get things going quickly. It was like a quick POC we were going to do, and then like a month later we had to deliver like a demo on it. So we didn't really have the time or support to build our own API, and so we tried out Hasura and it ended up working great. And so now we're still using it now, and we're pushing other teams to start leveraging it just because it's simple and super fast. And yeah,
When you say other teams, I'm just curious, how big is the development side of Renaissance?
it's a lot. there's multiple teams, hundreds of engineers, right? Yeah, it's a developer software company first and the
Okay.
education company second. So
I like the way you phrase that. That's good.
yeah.
So in particular, how did you folks start using Hasura in the first place? Like what was the actual product that you built out or the POC, that kind of thing?
So the first POC was just Hasura was our middle layer API. So we were using JWT tokens to authenticate and get authorization. And then we were just having it connect to a simple Postgres database that was storing things in JSON-B columns. So it was just one giant payload that we threw in there per like user that we would return some data, not uh, tables or anything, just one column, one table. So that was a little bit simpler and a little quicker to get going. And that data was exported from Snowflake like on a daily cadence. So it was dropped into an S3 bucket, Postgres, or the Lambda picked it up and pushed it into Postgres. A very simple pipeline, right? But
Yeah.
as things got larger and larger, that pipeline became more and more complicated. So that sort of will segue us into how we're using it now, which is we have it connecting directly to our Snowflake service that we're using. So Snowflake is a giant columnar database analytics software thing you can purchase for lots and lots of money. So we went from syncing data into Postgres and the cost of that and the dev time and the resources and the complexity of running a pipeline to pull millions and millions and millions of records all the time into Postgres just became too much. So we decided, hey, the cost of this is a lot. Let's try just connecting directly to Snowflake, which also has lots of costs with having it act as a backend data source for a front end application, right? But leveraging some of Hasura's caching and building our Snowflake tables in a certain way got those costs down to like a lot cheaper than what it was to run the pipeline. So
I'm sure those cost savings are not only in dollar values, right, but they're also in performance.
Yep. So we did like a small comparison test of like, what's the response time of like making a call to Hasura and having it hit Postgres versus the response time of having it hit Snowflake. And it was different, but not different enough to where the user would recognize it, right? It was 200 or so milliseconds for the Postgres endpoint, anywhere from 300 to 500 milliseconds for the Snowflake one. So half a second at the most, which is, for the most part, really good for a front end application to respond for those API calls. So
Yeah.
yeah.
And from what I understand as well, right, you folks are using the caching feature that we have as
Yep.
well.
Yeah.
Yep.
Yeah. So we refresh our Snowflake, the data we're pushing, or the data we're displaying to our users is refreshed every 24 hours. So we're able to cache it. We cache it for 12 just in case we want to refresh things a little sooner. But yeah, we use Hasura's caching. It works great. Those cached calls return in under 100 milliseconds. So super
Yeah.
fast.
And this is a loaded question, but how easy was it to implement that caching feature?
It was really easy. Initially we used Hasura self-hosted, and that was a little bit more complicated because I had to build the Redis cluster and all that. But when we moved over to Hasura Cloud, which was just a few months ago, it was super easy. Just turn it on.
Yeah. Just add that caching directive on your query, and
Yeah,
there you go, right?
exactly.
Yeah, I love that.
Yep.
I love that.
Yeah, super easy.
Well, awesome. Is there anything that you want to tell folks a little bit more about Renaissance Learning, or anywhere they can go to find some more information about you folks and what you do?
Yeah, so we're available right through the website. Go read about Renaissance. It's a great company. I love working here. The products we offer are awesome. We're really focused on putting the teacher first so that they can support their students. Yeah, it's pretty neat.
Awesome. Good deal. And lots of products that are out there, so lots of different choices.
Yep.
Jesse, thanks so much for joining us today. Happy to have you here. And if anybody has questions, Jesse may stick around for a few minutes and can answer them in the chat. Otherwise, we'll see everybody online. Thanks, Jesse.
Yep. Thank you.
All right. Next up, we have Sandeep. So Sandeep, if you'll go ahead and join me up on the stage, we're going to be taking a look at DDN Advanced today. Sandeep, how are you?
Hey,
Yep.
great.
Awesome. For all the folks on the call, Sandeep was demoing a few things last week in our all hands meeting, and I told him he should change his title from senior engineer to senior magician because there's some really cool stuff that he's been showing us. And I know that everybody's really excited about this concept of kind of a multi-repository workflow inside of DDN Advanced. So you want to give us a little introduction, and then you can jump into the demo itself?
Sure. So FYI, the magic stuff is not ready for public eyes yet. This will amaze people in some time later. But yeah. So Akshay in a previous community call has talked about what federation is, how is it different from other people who are doing federation in the market. So I'll not touch upon that. I'll just give a basic overview of federation. Let me show. The key differentiator between Hasura Federation and others is we have the concept of subgraphs, which are like individual modules, which when brought together gives you the API. So this is unlike the sort of like GraphQL gateway or a adapter, sorry, gateway or like a relay, which splits across like subgraphs in their concept. So this is how DDN does it, where you have individual modules and you can compose them to form your subgraph. What are the advantages we gain with this model? We have built-time validations. Like if it builds, it works. If your supergraph build works, if it builds properly, it will serve the API properly. You have that confidence. And one of the biggest advantages of the subgraph model is that you can release your subgraphs independently without breaking or obstructing any other scene subgraph. Like you have independent SDLC with each subgraph. So subgraph is a team boundary, and with that, that eventually leads to better composition. So you can compose multiple subgraphs, and that results in a new supergraph for you. Each subgraph can have multiple versions, and each one is an immutable build. So you can compose to form a supergraph build. And the fact that GraphQL engine, which serves the DDN engine, which serves the API, has the entire metadata with it, that leads to better query planning, and that results in better performance. So having said that, currently, if you had created a project with DDN CLIV 1.0.0, you would have done DDN supergraph build create, and you would have passed a supergraph.yaml, where it would have built multiple subgraphs together. The new concept that's coming in with federation is you can independently build each subgraph. And this becomes even more powerful, where each subgraph is present in different repositories. They don't even have to be co-located in the same repository. You can just build a subgraph, apply it, or use it to compose a supergraph build. So now what supergraph build becomes is just a composition of multiple subgraph builds. I can say, hey, my subgraph A, I take A7, B, I take B3. So as I said, each subgraph is by a module itself, and it has its own SDLC. So for a demo, I'll be demonstrating like a brownfield application, which basically it's our docsdb, where I have two models in my subgraph one. I have products and orders. There's a relationship between them. And I already have an API for this with this one single subgraph. It is up, and I already have the API for this. So this is a pre-existing API. Now, as a supergraph admin, as a multi-team manager, I want to onboard one more team called team 2, which with a subgraph called SG2. Basically, they will manage my users model, and I want to have a combined API for this. So, and this is going to be in a multi-repo scenario. So as a supergraph admin, I'll just create a new subgraph for them called DDN subgraph. I already have a project, and I'm creating this new subgraph called SG2 in this project, Enormous Bullfrog. So this way, I can onboard a new team in this subgraph. So let me create a new repository for team 2. And so the getting started for a federated subgraph is basically the same as a supergraph. The steps are literally the same. So let me run them in one single go so that I initialize a supergraph. You still need to initialize a supergraph so that you can do a local dev with that subgraph. Subgraph build that never gives you an API. You need to create a supergraph build out of the subgraph build to have an API. So I have my local supergraph initialized. Let me set the context. I'm setting the project and the supergraph file to context. I'll initialize a new subgraph called SG2. The name has to be the same as what the supergraph admin created it. Let me set the subgraph to the context. Just to note, this is all happening in a separate repository. Team 2, team 1 was the source for the API that we saw in the screen. Let me initialize the Postgres connector. It automatically connects to the docsdb. By the way, these steps are as is from our getting started docs, so they are no different. I introspect my Postgres database to get the database schema. I add a connector link for my database. Now let me start everything locally. I'm doing local dev with my subgraph. I have all my services running. Let me update my connector link with the schema. So this is my subgraph 2. I have my metadata and my connector link is updated with the NDC schema for the database. Now I want to add a user's model. I'll add that. I have my user's model here. Now, just like I would do a supergraph build local for a non-fitted scenario, I need to do the same thing for me to see that API locally. So I have my local build. I go to my local console. And I can see that the user's model has been tracked for subgraph SG2. So I can query the user's IDs and email. So I have my new repository with my new subgraph building locally. Now let us push this subgraph to cloud. DDN subgraph build create. I'm creating a subgraph build for SG2. This is creating before we can push the subgraph to cloud, I need to build my connector. So let me build and deploy the Postgres connector to DDN. And this will also update the URL in target DNV file. So if you can see, all the steps resemble closely with the supergraph getting started. It's no different.
And so Deep Wellness is building in the background, right? One of the things that we're seeing in future iterations of the CLI workflow is going to be, as you said, some simplified commands as well, correct?
Yes, it's going to be like 5 commands. Like right now, we have the building blocks. Now we are going to give you the wrappers with which it is going to be very easy to work with DDN. We've heard the feedback that it's too difficult. We acknowledge that.
Totally.
So now I've built my connectors. Now let me build my subgraph. Now I have built my subgraph with this version. Now, as I said, subgraph doesn't give you an API. You need to apply this subgraph build in that project. We have seen that in the project right now, we have only these 2 models. Let me apply a subgraph build in this project. Now, what's going to happen is this new subgraph is going to get merged with this already existing subgraph. So a new build has been created. As you can see, the user's model we developed independently in our local is now merged with my supergraph. So let me try querying all of them.
A little redundant query there at the end, yeah. I'm seeing a lot of emoji reactions coming through of people excited about this.
Great. If you're excited about this, the next one will probably excite you more. Now we have a great API. It's all good. Now, the true power of this API is unlocked when you can join stuff across subgraphs. Like now I want to get all my users and their orders and what products they have ordered. It is basically joining across subgraphs. Now, to do that, I basically create a relationship in my subgraph 2 from users. I join it to orders, which is present in subgraph 1. So I'm joining based on these two fields. This is just like any other relationship you would create inside subgraph. It's just that now the target is present in a different subgraph. So let's do this. DDN subgraph build create. And let's apply this. Now the build is applied. Now let's make a new query. Now I'm going to get all the users and I want to get all their orders and each of the products that they've ordered.
Sandeep, maybe check your metadata real quick. Did you save that file before creating the build in VS Code? Yeah.
Good eyes. Very good eyes.
Well, that's like Shaya's eyes. There we go.
Now look at the information that we can get. I can get my users, their orders, and what the product that they've ordered. Now imagine you can query, you can filter with these cross subgraph relationships. You can make aggregate queries with this. You can even power your permission models with these kind of relationships. When you have such a flexible API backed by a powerful authorization system, that unlocks a lot of things for you. So just to highlight the key points, the subgraph model lets you iterate and deploy very quickly. And this supports a multi-repo scenario, which is a common case with large enterprises anyway. So what's coming next? As I said, a magical workflow to make getting started easy is on the way. And we have schema registry and schema diff, which are required features for CI/CD. I need to check whether my schema is backward compatible, and then I can do a safe release. And RBAC. When I say RBAC, it's basically I'll have roles for supergraph and subgraph. Each subgraph can have users and admin. Users can create bills, admins can apply bills, and this applies for both in supergraph and in subgraph contexts. So these are all in play, like these are all being developed actively. And even today, you can see in the console, you can look at the subgraph builds that you've created, the subgraph builds that you created, and all the subgraph builds that are backing those supergraph builds.
Got it. As a hater of monorepos, this makes me really excited for being able to, I would think, move somewhat independently, right, really quickly, but still have guardrails in place so that I don't mess up anything that's in prod. So that makes me happy.
Exactly.
Yeah.
It's still like if it builds, it works. That philosophy still stands.
Awesome. Awesome. All right, so you're going to stick around for a little bit in case people have questions in the chat. I saw a couple of things come through, but I think they may have been from earlier. But we can check the Q&A section. But Sandeep, thank you so much for joining us today.
Thank you, Rob.
Yep, absolutely. Next up, I am going to ask Rahul, who is no stranger to this show, to join me up on stage. He's going to be talking about the GraphQL connector, and he has a video from one of our staff engineers, Lyndon.
Hey, Rob, how's it going? Hi, everyone.
It's doing well, doing well. All right, in the interest of time, I'm going to turn it over to you. I know people are excited about this. Let's hear about the GraphQL connector and how we can bring GraphQL sources into our DDN projects.
So, folks, Lyndon, part of our engineering team, and led the development of the GraphQL connector. So let's hear from him what GraphQL connector is all about and see a brief demo.
This is Lyndon. I'm just here to introduce you to our latest connector, which is called the GraphQL Connector. If you're familiar with V2's remote schemas, this is remote schemas for V3 in the form of a connector. So I'll run you through a little bit of information and background, then show it in action and dive into some of the specifics of how it's configured and how it works. So like I said, this is the remote schemas feature from V2 kind of ported over to V3 using a connector as a platform. Among other things, this allows the federation of V2 projects into V3 supergraphs, but it can also federate other GraphQL APIs into your supergraph. This is implemented via our commands specification rather than our collection specification, if you're interested, which allows us to almost seamlessly proxy a GraphQL API and expose it as root fields in your V3 supergraph. We introduced some new features into Hasura V3 in order to make this happen. So if you're interested, you can look up argument presets and field arguments. These will allow you to configure how authentication headers and things like that are passed through, and the field arguments allows it to mirror the upstream API via a top-level command. So if your upstream GraphQL API and your V3 project share the same auth provider, you should simply be able to pass through your auth in the authentication headers, and everything should work quite seamlessly. If you have kind of static authentication, like you want to just expose a pre-authed API, you can do that too. Also, obviously, public APIs are fine. The configuration is very intuitive and straightforward. So the bulk of the configuration is actually generated via introspecting the upstream API and saving the GraphQL SDL. This is the standard GraphQL schema format, and all of your tooling should continue to work with this. I'll give you a little demo of the supergraph in action with two different GraphQL APIs, a Hasura API and the public countries API running in parallel. And this is the set of commands that you would need to run to add a new connector proxying a GraphQL API into your federated supergraph. So obviously you need a supergraph, you need a subgraph. And once you've done that, you can add the GraphQL connector, introspect the API after you've configured the location, add the link, make sure every service is running with Docker Compose Watch in this case, then update the link, and finally do a supergraph build to expose it. So I won't do all of that now. So saving some time, I'll just show you. So this is the API in action here. So all of these customers and employees are from the Chinook dataset exposed via Hasura V2 API. And then down here, the countries API is exposed from this public Trevor Blades countries example API. So you should be able to, for example, query countries, and then also, why not, tracks. Let's just remove countries so that we can see the tracks at the top. There you go. So, I mean, nothing mind-blowing going on there, except the fact that we're now kind of proxying two GraphQL APIs in parallel via Hasura V3 via the GraphQL connector. So now I'll show you a little bit of the configuration involved in this. I'll just show you the countries example in this case so that we keep things a bit simpler. So here's our subgraph, here's our connector. So you'll have configuration.json split into introspection and execution. This lets you introspect a local dev copy or something that provides different information if you want to. You can choose to hard code or forward headers on each of the requests. And in this case, since it's just a public API, we don't need to do anything, but you could set authentication here, for example. After you introspect, you get back a GraphQL schema that you can modify if you want to ahead of actually importing everything. And then finally, when you add and update the connector link, you get your connector link configuration and then your set of models here. So that's it, basically. So if you've got any questions, please obviously reach out on one of our channels, maybe Discord, email, or other. But I hope you've enjoyed the show. I'm Lyndon, and this is the Hasura GraphQL Connector. And if you want more information, then please go check out the README and the repo up here at, I'll put it on the slides, this location.
Rahul, anything you want to say to cap that off?
Yes, I just want to kind of talk about one small setting which would help current V2 users. This was a NDC GraphQL repo, and it has a lot of information on how execution, introspection is happening. The one thing which I wanted to point out is that there is a setting of naming convention. If you put that naming convention setting, you will not have, you can remove namespacing, which DDN adds on top of the V2 graph. And this way, your GraphQL shape will remain the same in V2 as in V3. And this is the repo which Lyndon shared. And please try it out and let us know on Discord or GitHub issues if any problems. But thank you so much.
Yeah, I was writing some documentation for this yesterday, and when I imported a Hasura GraphQL schema, the visualization and the number of commands that just shot into my DDN supergraph was pretty impressive. So it's cool to see all that coming together.
Awesome.
Yep.
Yeah, so the next topic is providing a REST output on DDN. And it's a little different from RESTified endpoints for all the V2 users on the call. So these are like the top themes which we are targeting with REST output on DDN. That is the RFC on that link. I'll also share it in the chat. So please have a look and let us know any thoughts on any of the technical direction we are going with REST output on DDN. But there are like 4 major points which we want to kind of let the community know on how we are proceeding with REST output. First is auto generation of REST endpoints. So you bring in a model from any data source, and using the model configuration, we will provide REST routes for all those models. We are also adopting the JSON API specification. So our REST response data document structure, for example, and the URL structure would be JSON API compliant. Thirdly, high flexibility with strong type schema, and I'll show you what that means in a brief demo, which I will show in the rest of the call. And lastly, something which we are very excited about is that solving the high quality API client experience in REST. So giving you like a GraphQL-like client experience with REST, with features like autocomplete on deeply nested fields and type safety, which you enjoy with GraphQL, but not very feasible with REST APIs. So with that in mind, I would say here is the RFC, which I'll share the link here for you to, if you want to go along with me here. But when I mentioned JSON API spec, imagine that you have an articles model in the metadata. So you have your model definition where you have metadata constructs like filter, expression type, and then deep diving into it, you could probably see the different Boolean expression types. which you can configure in your supergraph modeling framework. Now, all of that kind of auto-generates API routes for you. So this is what we meant by being JSON API compliant, is that this is a sample example. This is an example of how you would do nested relationship using keywords such as include, and able to make complex fetching such as these right now. And that's JSON API compliant and giving you the composability which you really enjoy with GraphQL. The point is that all you need to do is connect your data source, have Hasura create this model configuration, and just like you get a GraphQL API, which is highly composable, going forward, you will get REST endpoints as well. So to kind of give you more insight into how the user experience would look like when we release this in a few weeks or month time, we have created a mock server called JSON API experiments. You can go through the code here as well along with me. But what we have done here is kind of mimicked our supergraph modeling metadata in these TypeScript types. So just like we have, these are the Boolean expression types you will get when you introspect a database in Hasura. This mock server has those very similar interfaces like article filter expression, where these are the different options available for you. These are the fields you can filter on it. These are the fields you can sort on it. But here you can now see the flexibility we can provide is that you can decide which fields to sort on, which fields to filter on, which operators to expose. And we will auto-generate REST endpoints. The Hasura engine going forward will provide these kind of routes to different models with that sorting, filtering, and pagination capabilities, which is highly customizable. And the best part of all of this is that once you, as the API producer, have provided these like very simple configuration of how you want to interact with the API consumer and what you want to expose, we will provide open API specification. And as you can see, the open API specification has all those bells and whistles in it, such as operators and what can be filtered on and what can be sorted on. And once we have and this is what I meant by a strong typing and these points here around high flexibility with strong type schema, is that you get this flexibility and then you get a very detailed open API specification. And once we have that, we can start providing you GraphQL-like client experience. So let me show you a brief demo of how you would interact with REST APIs in DDN going forward. So in this demo, as I mentioned, this is a file where think of this as a supergraph modeling metadata, where you are defining the different configuration you want to be exposed as REST endpoints. This is what Hasura engine will expose by default. You don't need to write any code for it like you do in RESTified endpoints. And this is the client experience, as you can see. We are just using some TypeScript libraries out there to generate the client based on the open API schema. And
Rahul, could you zoom in just a little bit or make the text a little bit larger for us? Oh, sorry, this is a recording. My apologies. That's okay.
Yes, I can show in the code after this demo a little bit and zoom out. But I just wanted to kind of show the autocomplete experience on the GraphQL client, GraphQL-ish type experience here. So as you can see, I'm able to get autocomplete on what fields are available to sort based on the open API specification. I'm also able to get what are the different operators available to me for filtering. And it is giving me error hinting as well on VS Code or the text editor of your choice, such as this. So this is what we are planning. Let us know if this meets your need, and what else would you like us to kind of think about as we are releasing this feature? At some points we are looking for feedback is our choice for JSON API specification as that data convention. And just the fact that now Hasura can give you auto-generated REST endpoints. Let us know how you think and any feedback you have on this. But this is the client experience I wanted to kind of show. And to Rob's point, I will just zoom in this a little bit by going here. So if I go to the client and within that I go here. So this is what I was showing in the demo, like very GraphQL-ish type, but the client experience here. And once you have this open API with all the information, you can use a tool like, for example, Stainless API, which we've been exploring and partnering with, where you can like start drilling down into and get a very kind of intuitive and nice experience to work with REST APIs and export SDKs in the language of your choice. So think of it as like another way of consuming the Supergraph in a way which is very native to how you work already.
This is really exciting. And you said that the RFC is where people can give us feedback. Is that correct?
RFC, yes. GitHub issue, like the PR request, provide any feedback, Discord. These are the two channels, please. And we are working on this right now, soon to be released. But thank you again, everyone.
Excellent. Thanks so much, Rahul. So next up, I'm going to bring Rakesh on the stage. We're going to talk a little bit about multi-source query filtering. So I'll give him a second.
All right, fine. Hi, everyone. This is Rakesh. I'm a senior engineer at Hasura. I work on core API engine and metadata build service. Today, I'm going to show you a feature that we are working very lately. That is multi-source query filter. So before diving into the feature itself, let me give you a quick recap of the capabilities with respect to the multi-source joining that currently Hasura DDN has. So Hasura DDN allows you to define relationship across any model from different data sources, and you can also query the relationships. You can query the remote relationship. Let me give you a quick demo how that works. Before diving into demo, let me give you a brief walkthrough about the schema that I am using for the demo. I have like 3 tables in one database and another table in another database, and DB1 has products, customers, and locations, and DB2 has reviews. So for this, I'm storing my reviews in another DB. Let me quickly go through the console and try out the APIs. So right now I'm actually using the DDN local development workflow. So if you see, this is a console that you can open and test your APIs when you are developing locally. So if you see here, it's saying that it's unable to connect because I didn't start my local Docker Compose services. So let me quickly open that for you. So this is my DDN repo. Let me give you a quick overview of my DDN project. So right now I have two subgraphs. One is app, the other is reviews. So review has review table, and the app has all other tables, let's say products, locations, and customer. So in one of our previous demos, my colleague Lyndon has shown you how to how to build API using the DDN commands. So I pretty much followed the same commands. Let's start our local Docker Compose services. And yeah, I'm just spinning up my local services. Let's go to the console. So it shows it's connected. So right now I'm querying products and product reviews, right? Products and product reviews, and this is the remote relationship, and this data is coming from other DB. Similarly, customers and customer reviews, same. Customer reviews is a remote relationship. And then next, the feature is you can actually filter your data based on your remote relationship predicates. So let's say if you have a remote relationship, you can filter based on the comparisons on your remote DB columns. So let me show you that how we can achieve that. So here I have these products. So I'm trying to review get my products and which has at least one review that says that has a keyword good in it. So let me quickly make a query. So here you can see I have all my products which has at least one review that has good in it. Let me also change this and put fantastic. Let's see how many products has fantastic in their review. So yeah, there are a couple of products. So let me change it to, let's say, bad, right? So okay, there are no products with bad. So my catalog is pretty much fine. So all products has positive reviews, right? So let me show you another example. So here I am fetching the reviews based on based on the customer who posted the review. So I want to fetch only reviews that are from my location. Right now, my location I'm filtering based on my state. Right now, I set it as IL. IL is Illinois. Let me fetch those. Yeah, these are the reviews for this reviews. These are the products and their reviews, where the reviews are posted by customers from Illinois state. Let me also change this to New York, NY, right? So yes, I got the products with the reviews that are posted from the New York state, from the customers residing in the New York state. So yeah, this is the thing, and this is live currently in production. You can try it out and let us know. And so what's next? So we are also planning a couple of features that is based on this remote relationship query predicate filters. So one is to be able to use these predicates in filter permissions. So this is very powerful features. Let's say if you want to fetch reviews based on the customer's customer's account creation state. So you want to actually remove the reviews that are created by the customers and whose account has been created very late, so that you can just filter out the spam potential spam in the reviews, right? So that is one thing. And yeah, there are obviously a lot of other use cases where you can use this remote relationship permission in filtering your permissions. And then the next feature would be you'll be able to use aggregates in your filter predicates. Let's say if I want to get the products whose average rating is greater than, let's say, 4, so you can directly use the aggregate. So we are planning this. So the feature the first feature is in work in progress. So we'll be going to release this in next 1 or 2 weeks, and in coming weeks or months we will release we'll work and release the filter based on aggregates on array relationships. Yeah, thank you. If you have any queries, please reach out to us, Discord, any other channels. Also, please keep an eye on our product updates. So a lot of new features are in the roadmap. So yeah, and try it out and give us your valuable feedback. That's it.
Rakesh, thank you so much. Out of curiosity, did you make that dummy data yourself for the database with the reviews?
Yes. Yeah. Thank you. Yeah.
No bad reviews.
Yes. Because thanks to OpenAI, it actually generated.
That was the plug I was going to make, man. That's, for me, that's been the best use I've seen of an LLM so far, is just, here's my schema, give me some dummy data. And I won't call anybody out from the company, but I've seen somebody padding their own docs feedback reviews and giving high marks to their own documentation they've written. So we'll leave that as an internal discussion for who that is. But yeah. All right. Thanks so much.
Yeah. Thanks. Yeah.
All right, folks. Everyone here, you're witnessing history. We are going to end our community call on time for probably the first time ever since I've been hosting this. So congratulations for being a part of history today. We have one section left, and that's going to be product updates. So hopefully you can see my screen right now. Let me jump over. There's 3 things that we want to share with you folks real quick. First off, if you have used our GitHub integration in V2, we started to think about ways of automating deployments for Hasura DDN. So we have a GitHub action available, and the link is in the resources for the call itself. And then we'll email it out with the wrap up for everything from today as well. What this allows you to do is anytime you have, for example, a pull request, you can have this action actually go ahead and create new builds, generate the preview link for the console down below, so you can have that quick iteration for CI/CD, getting feedback from team members before moving things to different stages of your application itself. Additionally, you can have it work in really any branch that you have with your repository and have this set up with CI/CD. So a very cool thing there. If you don't want to grab the link, it's just called DDN deployment. You can find that on GitHub. And huge thanks to Suraj for the work that he's been doing on that. I think he's on the call right now, so if there are questions, he'll hang around for a little bit and we can answer those. For anybody that's been using native queries inside of DDN, it wasn't the most parsimonious experience of being able to kind of write them and get them into your supergraph. So there's been some great work from our teams on actually kind of automating this. So now what you can do is go through and actually just write your SQL, and then using a connector plugin, you can go ahead and point it at that file, and you will get your native query automatically generated, and then you just track it in your supergraph, and you're good to go at that point. Right now, the page that I have up is listing native queries for Postgres. And again, we have the resource for this documentation page linked inside of the resources section of this call. So please go check that out there and give it a run. Let us know what you think. And finally, I saw this come up at the very beginning. Somebody was asking questions about point mutations in Postgres. Guess what? They're here. You have this key value pair of mutations version, and you can set it to V2. We're working on beefing up this documentation and making it a little bit clearer, because right now in our getting started section, we're still talking about things like using a TypeScript connector and doing things like CQS. But instead, you can actually go ahead and expose mutations as commands inside of your supergraph using this key value pair. Again, that's linked over in the chat. And within the next week or so, I'd say we'll see some clear documentation coming through for how this works and how you can get it started inside of your projects. Let me jump back over to our deck real quick. We do have 2 webinars that are coming up. One is on data mesh and domain ownership with Ken and David. You can see that on August 8th at 9 a.m. Pacific. And then a few days later, we have Praveen, who is working on building high-performance APIs and Elasticsearch with Hasura GraphQL. If any of these topics interest you, come check these out. It's a great opportunity to get some really concentrated time with these folks that are experts in these areas and can answer lots of questions that you have. As always, though, we have Discord office hours every Tuesday at 10 a.m. with Tristan in particular, and a few of us will jump in whenever we have time. You can ask any questions you want to in our Discord server, or jump into those office hours and get some one-on-one time with not only community folks, but also with the engineers that are responsible for all the great work that is happening. And finally, we're always looking for feedback. We're always looking for participants like we had from Renaissance Learning in the beginning of this call. So if you want to jump in and share your Hasura use case and a little bit about your company or what you've done with Hasura, we'd love to have you on and have a conversation. Other than that, we will see you folks in the next call in August. And thanks so much for being here today. Everybody have a great day.